Hello class. Today we're going to be working on the last topic for chapter 7, which is choosing the right model. And in this sheet we're looking at data of iPhone sales, all the way from the original iPhone in 2007 to the 6S in 2015, and looking at how sales went up as the different models were released by year. And we're going to look and see what the relationship looks like here. So I'm going to graph the year as the explanatory variable and the units as the response variable, because I believe as the years go on, the amount of units they sell is going to be going up, but what kind of relationship is that going to be? So you're going to go to Staplet. So go ahead and open Staplet, and I'm going to input the year as the explanatory variable and the units as the response. So go to Staplet, and on the front page we're going to be using two quantitative variables like we've been doing. And on two quantitative variables, for explanatory put year and type out all the years, and for response put the phones sold, iPhone sold, and type out all of those, and make sure you don't miss any, because these go with each other, right? Like 2007 goes with 0.5, 2008 goes with 1, 2009 goes with 1. So make sure you type it in correctly, and if you need to, go ahead and pause the video and get that typed in. All right, so now that we've got these in, I'm going to hit Begin Analysis, and you can look at the scatter plot here. And this is what my scatter plot looks like. You'll need to plot it on your paper. I've got it right here. You should have it on your computer as well. But you can see it doesn't look like a straight line. It looks like it's curving a little bit, like that right there, like it's curving. So what they ask is describe the form of the distribution. The data look curves. It looks curved. And then they say use the applet to find the least squares regression line, which is the linear regression line. And let's go back and find that. First we'll find the correlation, 0.95, that's pretty solid. And then we'll do the regression line. And there's my regression line. It looks a little off. And here's my equation. Negative 3088.78 plus 1.53833x. So we're going to put that in 1.54x. So y equals 1.54x plus 3088.78. 1.54x plus 3088.78, and it's it's minus, my bad, minus 3088.78. 1.54x minus 3088.78. All right, so I've got my equation right there. And the next thing we're going to look at is the residuals, and you'll need to plot the residual plot. And take a look at the residual plot here and see if you notice something. It has that U shape that I've warned you about in the past, that you cannot have a U shape like that because that suggests that there's a curve in the data if it has that U shape right there. And that one definitely has it. You're going to want to plot that on your paper. And we're going to talk about that having a U shape, which is not a good thing. So does the residual plot suggest maybe the data is not linear? Yes, it suggests it's curved. The residual has a U shape. Therefore, it suggests the data is curved. So that would suggest that our data is probably curved. And we need to keep that into consideration here as we go on to the next part of the problem. because perhaps a linear regression is not the best model for this data. So you have the applet create a quadratic regression model, and we're going to sketch that plot. So let's look at a quadratic model. And what I'm going to do is go back to Staplet. And I'm going to go down. You go down further, it says calculate a different regression model. We're going to do quadratic and calculate that. And let's take a look at the quadratic regression model. That line looks a lot better here. It looks like it fits that data a lot better. So it's already looking like a better line. And then look at the residual. This residual does not have that U-shape. Because remember, a U-shape always suggests it's a different shape. So if it had a U-shape on the curved model, that would mean maybe it's linear if you tried curved first. So if you have a U-shape on any model, it suggests it might be a different shape. So that residual looks good. And also notice the residuals are closer to the line. See how it's negative 0.4 and 0.6 over here? Let's go back to the line, the linear. When I do the linear, they're like all the way up to 2 away from the line up here. So they're further away. I'm going to go back to quadratic now. And see, this one is within 0.6 every time. So go ahead and plot that residual. And that's a much better residual than the linear one. And that is pretty good evidence that the quadratic curved line is probably the better choice here. So go ahead and plot that right there. And the next thing we're going to talk about is the R squared. The R squared. And if you'll notice, the quadratic regression model only has an R squared. It doesn't have an R value. It's impossible for anything but linear to have an R value, but it does have an R squared of 0.9951. So we're going to go and put that 0.9951. And the linear up here, this equation for the linear only has an R squared of 0.9057. 0.9057 for the linear R squared. So let's talk about what those numbers mean. And that literally is just the R value squared. So this R value is 0.9517 for the linear. And so R squared is just that number squared. And let me explain what this is, the R squared. The R squared value is called the coefficient of determination. The coefficient of determination, which is the proportion or the percentage of the variation in the response that is predictable from the independent variable. It's basically a percentage of how well these two are linked together and how well they predict each other. And when you're getting into different types of models like quadratics and exponentials, you're going to use the R squared instead of the R because the quadratic one doesn't have an R value. Let me rewrite that. That was kind of ugly. 0.9057, right? So it's basically the percentage of the variation that is predictable from the explanatory variable. It's how much it explains it. And this is an excellent measure of association between two variables and can be used to help choose which regression is the best fit, because a higher R squared means it's a better fit, it's a better predictor. But you also want to pay attention to the shape of the residual, and we did, right? The residual looked better on the quadratic one as well because it was scattered and the linear one had a U shape to it. But if we look at the R squareds, the quadratic is also better. It has a much higher R squared, which means it is a better fit. It suggests a better fit. So based on your finding, which regression is a better fit for this data, linear or quadratic? Let's say quadratic is a better fit based on a higher R squared value and a better residual plot the linear residual plot had a U shape. Which we don't want. So the linear residual plot had a U shape, which suggests that it might be the wrong type of plot. All right, so we've chosen our appropriate model, which is the quadratic, and they want you to extrapolate a prediction for unit sales in 2022. So we're going to use the quadratic regression formula. The quadratic regression formula. And so let's go find it. We have it right here. So there is my quadratic regression formula. It's a big formula. All right, so that quadratic equation is pretty big. You're going to need to copy it over to your sheet. I'm just going to literally copy and paste it over like this. And if I wanted to use it to predict, extrapolate a prediction for 2022, I would plug in 2022 for X. And so I plug 2022 in for X in both spots. And you're going to need a calculator for this. You can either use like an online calculator, or I'm going to use the TI Inspire and type this into the TI Inspire. And I did that right here. So I pulled up a TI Inspire calculator, and I typed all this in. And times 2022 plus 0.21333 times 2022 squared. And let's hit enter and see what happens. I end up with 43.08 million. So 43.08 million phones sold in 2022. And that's how you would make a prediction, an extrapolation with a quadratic equation. A little more complex than linear, but still not bad, right? You're just plugging in X and finding your value for the number of phones sold. All right, so that is the last topic in chapter 7.